When you're factoring a quadratic equation, and you do need to know what these look like, they look something like x squared plus, let's say, 4x minus 5. And what makes it quadratic is that you've got a variable in the base, and your exponent has a 2. Okay, it is going to be a type of a graph. A quadratic equation creates a special shape when it's graphed, and we call this shape a parabola. And there's 3 examples of them down here. So a quadratic equation can have 2, 1, or no real solutions. You're going to see these written as solutions. We'll either say find the solutions, we might use the word find the roots, or we might use the phrase find the x-intercepts. So here's a picture of what you're doing. If you have a parabola that looks like this, it's going to have no x-intercepts. How come? Well, because the lowest point is right here, and it just keeps going up, up, up. It's never going to cross the x-axis. So we say this has 0 real roots, or no x-intercepts, or no solutions. If you have a parabola like this that comes down and it just touches the x-axis right there, that has 1 x-intercept, or we say 1 root, or 1 solution. Or if you have a parabola that, and they can open up or down, so both of these pictures, this one would have 2 real roots, so would this one, 2 x-intercepts. And we'll connect this a lot more next chapter. This chapter, we're going to mostly work on factoring these things and figuring out how to solve. And then next chapter, we're going to do a lot of graphing. So these pictures will come back. Okay, so you have to understand why we're factoring. We're not just doing it because it's so fun to do. We're doing it because factoring helps you in algebra to solve that equation. That is, to determine what the x-intercepts are, because they will be your solutions to your equation. So what are the x-intercepts of that parabola? Because they will give you your solutions, your real roots. Okay, so let's do a quick review here. How do we factor? So we got this mixture. We've got nice trinomials that are easy to factor. How do you know it's going to be easy to factor? I call these IM trinomial. The leading coefficient is 1. You're looking for something that adds to the middle term and multiplies to the last term. Easy. These funky ones are when your leading coefficient is not 1, and then you have to break up your middle term. Difference of squares, that's your a squared minus b squared. Remember, a sum of squares won't factor. A squared plus b squared can't factor it. You need the square root of a negative to factor that. We don't do that in high school. Perfect square trinomials, you guys got, I said this a lot of times yesterday, sounding like a fool. Psst. Make sure you know how to factor those. Okay, so this one, it's nice. We're just looking for 2 things that add to -4 and multiply to -21. And I guess we can see right away, so if we do a factor tree, 7 times 3 is 21. And since I want it to add to a -4 and multiply to -21, I'd need to put negative there on the 7. How does that factor? X minus 7 and x plus 3. And always check your work, even when it's simple. X squared, check. Add 3 and subtract 7. Yes, I'm going to get -4. Last one, double check that you got your signs right. Okay, remember, with all of this factoring, the very first thing you do, because it's easier, is you always look at your GCF first. Especially when you see a leading coefficient. Is 3 a factor of all those terms? Yes. So take it out first. It leaves me with a squared minus 2a minus 8. So I don't have a difficult one to factor. It's really a nice one. The leading coefficient is 1. So what adds to negative 2 and multiplies to negative 8? Well, if I start a factor tree, 4 and 2, I can already see I've got it. I need the negative on the 2. So this gives me 3, bracket, a minus 4, a plus 2. Double check your work. So I'm going to make sure that this works. Oh, how about I use the same letter every time? So I've got a squared plus 2 subtract 4, check. Last check on the signs, it works. Okay, this one isn't nice, not a leading coefficient of 1. There isn't a GCF, because while 3 goes into these two, it doesn't go into there. And so before you start saying 9 times 4 is 36, what multiplies to 36 and adds to 12, and start off doing too much work, do you recognize your perfect square trinomial? When you see a perfect square and a perfect square, check the middle term. What are you checking for? Well, the perfect square, and you would need 2 of them. Is that what you get? 3b times 2 give you 12b? Yes. You've got a perfect square trinomial. So that factor, 3b plus 2, all squared. So train yourself to recognize it. Okay, this one's way more complicated. So it's not nice, not a leading coefficient of 1. There's no GCF to pull out, and it's not a perfect square trinomial. So I just have to do this kind of factoring. That is what adds to 7 and multiplies to 12, which is going to be 3 and 4. So then I'm going to use this to split up the middle term. Instead of saying 7x, I'm going to say 3x plus 4x. Okay, but notice that we haven't changed anything. These are still equal. This still is 7x. So then these two have a common factor of 3x. It goes into the first one x, to the second one once. Plus, these have a common factor of 4. It goes into the first one x, into the second one once. Then these two terms have a common factor of x plus 1. It goes into the first term 3x times and into the second one 4 times. When you factor like this, you need to look after and see if you still have a GCF. Okay, would you please try this one?